Everyone. Our final project is Language Identification from Children's Speech. My name is Chujun Chen, and this project is done by me and my partners Lan Ruojiang and Kun Gao. So this is a brief introduction of the background and the problem we have met. Because we are doing language identification, it can be taken as the initial stage of auto language translation. To identify which language the speech use, the system can connect the caller to appropriate human and machine operator. So this project is very helpful to ensure effective communication. And the problem is that we are dealing with children's speech. So because children are too young to have amateur speaking skill and reading skill, so the speech that they produce might not be very clear, so which can produce some problems on identification. And the dataset we use in this project is PL Star Corpora of children's speech. It contains three languages: British, German, and Swedish. So this is the framework of our project. This is the first part, the training part. So the first step we did was to extract feature vectors from its speech. And the feature vector we choose in this project is MFCC, male frequency central coefficients. Then after the feature extraction, we use HDK2s to perform EM algorithm to train UBM and GMM separately. So this is the first part of our code. The first function we made was to produce a TXT file containing file path. So because a TXT file is a very important source for the HDK2s, it is used to identify the location of the source WAV files. Then the second function was used to adjust wave frequency because the dataset we used recorded English and Swedish at frequency larger than 16 kilohertz, and the 16 kilohertz is the standard processing frequency. So we used SOX to transform the frequency to 16 kilohertz. Then the third function is to remove, so we can edit a file name to add some extension we want. So this is the very first step of our project, the transformation. We just use the transform function we made before to change the WAV file frequency. And then the next step is to produce label. Because the HDK2 needs a multiple sources file, like the WAV files, the corresponding label file, and the corresponding MFCC file. The MFCC can be produced by each copy, and the label file we can just made in Python by change the extension. It can be opened by the text editor. In text file, it only contains the starting time of the speech and the end time of the speech. Also, it contains a label saying that which language it belongs to. This label file can be taken as the as the answer of the test, so we can use it to calculate the accuracy of the model. Then the production, this production is used to produce the label file here. And then this step is feature extraction. I named it as MFC. In this step, we mainly use the hcopy to transform the speech from wave to MFCC file. And this is the comment line. So basically, the first thing that we are going to use hcopy, and C indicates the configuration location. This txt is a configuration we made for the HCopy, so it can produce the MFCC in the form we want. And hence we just browse all over the WAV file we have and then transform them into MFCC. So let's see, as indicated here, after we have got MFCC, we just use it to produce the UBM. UBM is a special case of GMM. It is, as we all know, that we use GMM to be the specific model for each class of language, but UBM is trained by all of the training data, no matter which language it uses. So basically, it just provide a universal background for the identification, so it can eliminate some deviation and enhance the calculation efficiency. Yeah, this step is also used to produce the txt file because we needed to declare the location of MFCC. And this step is to split the data into training set and the testing set, also produce the txt file. And this step is to combine all of the training data or the testing data so we can train them in a batch. We will go over this later. Yes, the first step to train the UVM with only one component. So in this step, we use the hint. Hint is a special HTTK tool that it can perform an initial guess of the parameter values. So it is the purpose of that is to giving a good starting point of the re-estimation. We want to train the model to get UBM or GMM. So the comment here is very simple, just one comment. So just declare that we are using hint, and T is a trace option by one that we saying that we are going to see some details from the comment window. And comment is used to specify the output location, and S specify the input location. So this txt file is a prototype HTML file, which indicates that how many states we have in this model and what's the transform probability matrix, was the initial main vector and the covariance matrix. This is made arbitrarily, that we can set whatever we want. And after this step, we can get UBM, and after we got UBM, we just use hrest. Yeah, here use hrest to do the re-estimation. So this is the training function. We use hrest, and there's a comment here. Use hrest to see the details in comment window. This is that we are going to localize the threshold values we want to see, because when the components getting more, some components weights might be very small, and if it's lower than threshold, which is than the default value in HGK, and it might be just show in the file that directly as 0, so, but we don't want that, so we use this. We just downsize the threshold values so we can keep all the records. M is used to also specified output location, and S indicates the input location, and this is the input HM file of the each rest, it is the same as the output of each int, so we can continue training the result of each int. So after training, we can get a GMM for each class of language. So this is the testing part. The basic strategy of testing was to calculate the probability that to measure how much the data fits in the given model. So by calculating this the probability from these three classes of GMM, we can make a comparison, and by selecting the largest one, we can get to know which class it belongs to. So hence the language can be identified. So this is the test function. We use hrest because hrest performs EML algorithm. So if we just make it run one iteration and get the outcome, we can just use the probability directly. And also the comment is same, except that in here we set iteration to be 1. And this is the script to run the test. We have 3 available class of languages, and this test list containing the location of all the testing speech. So after we so in every iteration we read from the trail text to get one location of the test data and write it to a new test txt file, so that this may contain lots of testing data location, but in this txt there's only one location. So every time you just test this only one only single data. So here we perform the test function that we already declared here, and after we got the probability, we just compare it with the maximum value to see which result it is, and we read the corresponding label file to see what is the truly label, what the truly label is, and compare to see whether it is identical. If it is, the identification result is correct, and if it's not, and it's wrong. So here we prepared a small demo for this project, and here there are 3 web files. This one is English, this one is German, and this one German. This one is Swedish. So in this trail txt, there are 3 locations. We just run this script to see the results. Here, we can see the first part. So as we can see here, the system just calculate the probability it fits into the English model, the probability it fits in the Swedish model and German model, and after the comparison of the probabilities, you can see that the result it got is German and the answer is German, so it's correct. And we can also check. So the answer is correct. We can also see this. So the text. So the first one here is this WAV file, and we can listen to this.
Diese sonderbaren Säugetiere gibt es an den Flüssen Australiens, Tasmaniens und Neuguineas.
Yeah, this is German, I think, and we can see that this is correct. And also, You can see all of the results here, and they are all correct. So in our practical testing case, we loaded about thousands of speech raw file, and you can see the result here. Yeah, this is the result. This is the result we first get, and you can see that accuracy is about 90%. With the increasing of the components of GMM, and except there is a little glitch here. And the reason behind this might be that limitation of EM algorithm, because EM algorithm can only find the local optima, not the global optima. So if the initial point is very bad, it has probability that it can get worse results, although it has more components in GMM. So the solution is that we just randomly select the initial points and repeat the testing procedure to see the accuracy and finally get average value of the accuracies. So this is the result after the improvement. We can see that there's no glitch here, and we can see the good tendency of the accuracy. As we all know that the number of components in GMM is a hyperparameter for the model. We would like to see its influence to the model accuracy, but we didn't see this tendency here. So we decided to use another kind of classification model, that is decision tree. So the first step here also feature extraction here. Because we have already produced MFCC file, all we need to do in this step was to extract the data from the MFCC file into the Python data form. So we can use another HTTP tool called HList here. HList can is used to show all of the MFCC feature vector on screen, but it was on comment window, so we just let it perform comment window and extract the content on comment window and save it as a list. So as we can see here, if we perform the batch production, the meaning is that we can extract feature in batch. And we can see that F means feature vector and R means result. It is the number of label, and we just can combine them together and use the decision tree module in sklearn. It's a very simple. It's very simple to use. So in this part, we want to test the changing tendency of the accuracy with the increasing of max depth of the decision tree. The max depth is also a hyperparameter for the classification module. And this is the result we got, as we can see. And at the beginning, the accuracy increases with the number of max steps, and when it got 15, it got the maximum point. After that, when the max steps gets bigger, the accuracy gets smaller. So we can see that if the model is too complicated, it might cause the decreasement of accuracy. The reason behind that might be the overfitting problem. So if a model is too complicated, it might just get messed up and miss the tuning point. with the chill label. So this is our project, and in conclusion, that we have already built some models to identify languages from children's speech successfully. And we also explore the relationship between accuracy with the hyperparameter. We also figure out the solution to the limitation of the EM algorithm, that it can only find local optima, which can result some bad accuracy. So our future work is that we would like to explore different application methods such as supervector and or other kinds of training model to compare which one is better in this case. And also we would like to explore the influence of feature vector selection. In this case, we use MFCC feature vectors, which is in 69 dimension. And maybe in the future, we like to explore that how the accuracy will change if we only use 13 dimension or 26 dimension. So this will all be done in the following work. Okay, that's it. Thank you.